about circular motion and how it is applied to our daily lives.
Ms. Braun, what's circular motion?
Well, Chrisanne, circular motion can be described as the motion of an object in a circle at a constant speed. Also, as an object moves in a circle, it is constantly changing its direction. Now, tangential speed is the speed that something's moving along a circular path. This is what it looks like.
So can an object be moving in circular motion and have both constant speed and constant velocity?
No, Emily, because an object cannot be moving in a circular motion and have both constant speed and constant velocity in a circle. The direction is constantly changing and velocity involves speed and direction, since it's a vector quantity, but it can have a constant speed without a constant acceleration. Does everyone understand? Does anyone know how inertia is related to circular motion? Think about tangent.
Maybe it's when the path of an object breaks, it falls in a straight line.
Good job, Emily. Inertia is related to which of Newton's laws?
His second law.
Come on, bob your head. Come on, bob your head. I'm gonna do it this right.
Perfect. The formula that we use that relates to the net force acting as centrifugal force is F equals MAC, where AC equals V squared divided by R. AC stands for the centripetal acceleration. So just like the centripetal force, it always seeks the middle. When you're representing your vector, you can label the centripetal force and the centripetal acceleration as the same line. Remember that. Would anyone like to volunteer? I will! Okay, class. Now please watch closely as Chrisanne swings around a string with a ball attached to the end. Pay attention what happens to the ball when the string breaks.
Come on, bob your head. Come on, bob your head. I'm gonna do it this right here. Bob hits, right here. Come on, bob.
Now let's interpret this example that Chrisanne just showed us into a free body diagram.
Come on, bob.
Now let's think of another real life situation.
Round and around and around and around we go.
Do you think that this is an example of rotation or revolution? It's actually revolution. When an object turns about an internal axis, the motion is called rotation. But when an object turns about an external axis, the motion is called revolution. Now draw the free body diagram. This is Fn, because the gymnast is holding onto the bar, and this is Fj, because gravity is always used. Now calculate the sum of the forces of Fc. So, Fc equals MAC. AC equals V squared over R. In order to solve for Fc, you must first find AC. So, 2 squared divided by 2 equals 2 meters per second squared. Now you can solve for Fc. So Fc equals 60 times 2. The Fc of the gymnast is 120 newtons. Now we're going to calculate for Fj. So Fj equals Mj equals 60 times 9.8, which equals 588 newtons. Next we solve for the sum of the forces. So that is the sum of the forces of Fc equals Fg minus Fn. Remember from our free body diagram how we had Fn here and Fg here. Those are the forces that you're solving for. So it's going to be, we know what Fc is, it's 120. And we know what Fg is, because we solved it over here, 580. And then we are solving for Fn. So it's going to be negative 468 equals negative Fn. And then just divide by -1 to make it positive, and Fn equals 468 newtons. This is the introduction to circular motion. Let's practice using a worksheet. If you need any help, I'll be right over.
Ms. Braun, I need help.
I'm coming right over. Okay. A mass is attached to a string swung horizontally in a circle of 3 meters when the speed of the mass reaches 8.1 meters per second. What is the centripetal acceleration? So first thing we need to do is identify all the variables and then plug them into the equation. So tell me what we know.
Okay, so this equation, AC equals V squared over R.
That's right. Now just solve it and put the numbers in.
Okay, I understand now. Thank you.
No problem.
Miss Braun, I need your help.
Try asking your partner for assistance, and if you need help, you can ask me.
Sounds good. Emily, can you help me work through problem number 2? Yeah, sure. Okay, so 1,450 kilogram car can just take the level curve of a radius of 48 meters at a speed of 20 meters per second in a dry road conditions. Given these conditions, what is the centripetal force acting on the car? So first, let's write down everything we know.
Okay, so we know the car is 1,450 kilograms, and the radius is 48 meters, and the car is moving at 20 meters per second.
Good, so the equation is FC equals MAC, but we don't know AC. So using the equation AC equals V squared over R, we can find the centripetal acceleration.
12,083 newtons.
Yes, perfect.
Well done. Good work in class today, students.